In this video, we're going to do a dilution. This is page 4 of homework packet 8, and it's a type D problem. And let's take a look at what we have here. So it looks like it says, what volume would 1,000 milliliters of 0.5 molarity KCl have to be diluted to so that the final molarity is 0.20? So if I dilute something, I'm going to add solvent, and if these are water-based solutions, I'm going to add water. And what's going to happen is my molarity is going to become less. It's going to be less concentrated or more dilute. So essentially, that same amount of moles of substance is going to be spread over a bigger volume of water in this case. So if I have some Kool-Aid and I say, oh, there's not as much, I don't have any more Kool-Aid mix, so I'm just going to add a bunch of water so it goes, I guess it lasts longer, it goes further, but again, the number of particles of Kool-Aid isn't going to change, but the volume of water is. Okay, if I take a salt solution and I dilute that, what's going to happen? The number of particles of salt or solute isn't going to change, but it's going to be spread over a bigger volume of water. So there is a formula to do this. It's V1M1 equals V2M2, where V is volume and M is molarity. And the 1 stands for the initial conditions, the 2 stands for the final conditions. So if you want, you can think about that as a little bit of acronym. You can vroom vroom. Okay, so chicka chicka boom boom. Will there be enough room? Let's try this. And let's see, V1M1 equals V2M2. So what I'm going to do is find my initial conditions. And it looks like I have 1,000 milliliters of 0.50 molar KCl. So I'm going to identify those and put those as my V1M1. And so I'm going to do 1,000. And notice that's in milliliters. And notice my molarity is 0.50. Whoops, we'll try that 0.50. And I guess I'll just put an M for that. But we know that that's a molarity. Okay, our goal is to find the final volume. So we don't know what that is. And our molarity at the end is going to be less, which makes sense because we're going to dilute it. So our molarity will decrease. So my guess is if I add water, my molarity decreases, but my volume is going to increase. And this formula will get you there. So it looks like I know 3 out of the 4 things in this formula. And I'm actually solving for, I kind of made a mistake when I pre-drew this up here. I'm solving for V2, so I'm going to throw the M2 into the denominator or divide each side through by M2. And I get V2 equals V1 times M1 over M2. And now I'm just going to plug in these numbers. So taking these numbers and putting them in, I'm going to get V1 looks like 1,000 milliliters. So I'll put that in parentheses 1,000, and I'm going to times that by the initial molarity, which is 0.50. I might just say 0.50 here. And then I'm going to divide that by my molarity 2, which is 0.20. So I'm going to take my oops, that's a comma, I think 0.20 right here. And what do I end up with? 1,000 times 0.5 over 0.2. I punch that into my calculator and I get, looks like 2,500 milliliters. Now, does that answer make sense? If I dilute it, it should take up a bigger volume. And notice this is asking for the total volume at the end or the final volume. All right, so notice I cut the concentration by more than in half, so I more than doubled the volume. So it actually is proportional. If I cut the concentration in half, it would double the volume, but I'm cutting it more than half, so it more than doubles the volume, and we can see that ratio that goes on there. There is one other part of this question. It says, how much water was added? So you can kind of look at this number and say, oh, I have 2,500 milliliters total. I'm just going to do this down here. So that's total at the end. So I might call that total. Okay, or maybe I'll say at the end. And initially I had 1,000. Okay, so initially I had 1,000. And I'll say that's initial. So how much did I add? Well, to go from 1,000 to 2,500, I must have added the difference between the two. And if I subtract that to get the difference, it looks like my amount added would be 15. See if I can write this in here, 1,500. And then I would say milliliters. I don't know if I'm going to be able to do that. I'll try that again. It's going to be 1,500 milliliters are ADD. Let's see, ADD are added. So I ended up with 2,500 milliliters. Initially, I had 1,000 milliliters. So I must have added 1,500 milliliters of water. So there are two questions here. One asks, what is the final volume? So that's this. This would be the B2 or final volume. And then what would be the, so I might just write final volume right here. Okay, and then the other thing that was asked, how much water was added? And that would be this answer right here. Okay, this one's typically what you're going to be asked for. You might be asked for a different molarity, but you can see how you do that, and it'll actually help you when we actually prep solutions. You know how much to add. It tells you if you were prepping a solution, you could start with the initial, and really, if you were prepping that solution, all you would have to do is add the water, mix it, and you'd be done with that. Just one last piece. Why does this formula for V1M1, V2M2, or VOOM VOOM work? And let's see, if I look at this, liters 1 times molarity is moles 1 over liters 1, liters 2 times moles 2 over liters 2. I cross out the liters 1, I cross out the liters 2, and at the end of the day, your moles of solute stays the same. So if you add water, your moles of solute stay the same. So that's why this formula works. Notice you can do it in milliliters or you can do it in liters as long as both answers are the same. Just report those. Okay, so skit, scat, scoodle doot, flip flop, flee. We'll see you at the top of the chemistry. Chicka chicka voom voom. We are done for now. Thanks for watching.